Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Greetings, everyone, and welcome back to another exciting episode of IT Pro TV. I'm your host, Justin Dennison, and well, we're back with a part 2 because we left a little bit of a cliffhanger here in our CompTIA Network Plus series. In particular, we're back to talk more about network topologies, and luckily we have someone in the studio who knows all about those things. Mr. Wes Bryan. How are you doing today, Wes?
Hey, I'm doing great, Justin. It's great to be here. That's right, we did. We left off in the last episode. We were talking about the types of network topologies that we have. We talked about wired topologies. We talked about wireless topologies in the first episode. And we really started to talk about, the layout of the networks, right? And it's really related to their geographical coverage area, if you will, the geographical location. If you remember, if not, go back and watch that first episode, and then we'll see you back here for part 2. But if you remember, in the first part, we talked about the difference between a LAN and a WAN, right? Talk about a LAN, local area network. Remember, I told you that it basically spans a single geographical location. Now, don't get too tripped up on geographical location, meaning, hey, is it a building, single floor in a building, multiple floors in a building? Again, it's just a single geographical location. Could be more than one floor in a building, but it's under the control of a single administrative body. Right? If you have multiple geographical locations, remember you can have multiple LANs and tie them all together, and if you're the company that oversees those multiple LANs, even though they reside in different geographical locations, then you have essentially what's known as a wide area network, right? So that's where we left off, and we're going to pick back up, and we're going to talk about a WLAN. Now, I know what you're probably saying there, Justin. Well, wait a second. We're talking about a LAN, and we're talking about a WAN, and now you just kind of mix both, letters together, right?
I just figured you were making it up. You were like, we have wide and local, and now we have wide local. I don't know what they are, but I assume that's what you're going to say.
Yeah, not really, but it's close. Good try, though. We've got consolation prizes at the door for them. We're looking at something known as a wireless local area network, right? And that is something that is really, really common. See, in other episodes, we talked about the wireless standards, right? We talked about 802.11 standards, right? The IEEE. Well, here we want to talk about the layout of the network. Remember, that's what topology is about, right? It's about the relationship of the nodes and how they are organized within the network, right? So let's dive into a wireless local area network, WLAN, all right? So if we jump right in here, I've got a little diagram here, and it shows you some of the major components that you would see inside of a wireless network, right? Now, we get a little technical jargon here, but just please understand, it really is, it's simplistic, right? When I talk about an STA, what are we talking about, right? We're talking about a station, right? That's essentially what a wireless device is, right? If I have a tablet that's connected to my Wi-Fi, if I have my cell phone that's connected to my Wi-Fi, if I have any device that is being managed and is connected to my wireless network, technically, according to the WLAN architecture, if you will, it's just called a STA, a station. It's a managed device within a wireless network. Then we have what is known as an AP, and a random word large there. We'll take that out of there. Not sure exactly why that's there, but it's gone. Then we have what's known as the AP, all right? And you might have heard the term that we've used in other episodes, a wireless access point, all right? Well, I just want you to understand that if we're talking about wireless local area network infrastructure, the wireless is implied. So that's why you'll see it just abbreviated AP, access point. All right, now, the next thing that we have, and a little bit more about the access point, right? The access point is the managing device, all right? And that's important because we have talked about things like in our wireless topologies, we talked about the difference between an infrastructure mode and an ad hoc mode back in part 1 of network topologies here, right? And remember, one of the things that I said is that in infrastructure mode, you have an access point that is the commander-in-chief, if you will, of the wireless network. It is the managing device. It's what controls the communication for all other devices, including management frames, beaconing, reporting what the network name is that we'll get in here as well. It manages the entire network. And again, this is what you see right here is infrastructure mode. Now, the next thing we have is what is known as a distribution system. All right, now if we take a look, the distribution system just looks like a little blue bar, but what really is that? All right, the DS, as sometimes they'll abbreviate it, because remember, in IT, information technology, we always have to have acronyms. We don't speak in English or whatever language you might be native to your location. The distribution system is nothing more than the wireless network It's interesting. I like the fact there that they call it an access point because it is confusing. When you look at a wireless access point, it isn't a wireless device. It's a wired device. The wireless access point, what its job is to give the stations access to the wired network, or in this case, the distribution system as they call it. That's all it really is. Now, when you have a single access point managing all of the devices on your network, you have what's known as a BSS, all right? Now, we're not talking BFF. That's a different term altogether, right? We're talking about a basic service set, all right? Now, sometimes you need a greater coverage area, right? So what can you have? Well, we can actually put two of these access points together, and both access points can essentially respond to the same SSID. All right, so there's a term that we got thrown at you, and we didn't explain what it is. What's an SSID? The SSID is an alphanumeric string that essentially identifies the network. It's called the service set identifier. And when you look at your computers, in fact, just right here on my computer, you know, Justin, I've got tons of SSIDs that we can actually see. We just call them generically, we call them network names, all right? Well, if you have a single access point that is managed by, again, a single SSID, it's broadcasting a single SSID, and that's the only access point, you have a basic service set. The great thing is you can expand the coverage area by putting two access points on the same network, essentially, and you have two basic service sets. When they're joined together and both access points are responding to the same service set identifier, it becomes what's known as an extended service set. Think about it as extending the range of the network, and this is where things like Wi-Fi roaming come in. When I leave the proximity of one access point, we have something known as the relative signal strength indicator inside of your devices, and when it says, uh-oh, I'm getting too far from this one access point, it starts calling out to the next access point, and guess what? The next access point says, oh yeah, I see you, you're part of the same network, right? I can see that you're part of the same extended service set identifier, so it starts to manage these devices. And that's essentially what the extended service set is, right? When you first see it, it seems like it's a little technical, but it's not. It's essentially two access points that are responding to the same service set identifier, and they're both managing the devices in a larger network, greater coverage area. But again, they're giving your wireless devices access to your wireless network. Now, the other thing that we also have to keep in mind is that if I do not have an access point, and honestly, I don't even have a distribution system, right? We don't even have to have a wireless network. If I have no managing device on a network, I have what's known as an independent basic service set. It's also ad hoc mode. And this is where your computers can form their own mesh-type wireless network. Remember, we're talking about mesh mode, mesh topologies. You don't typically see them in a wired network because of the exponential connections that it would cost having redundant connections to every other device within the network. Well, guess what? If I'm in an area where maybe I don't have access to, well, that's a little redundant, access to an access point, you can start a ad hoc mode or an independent basic service set. And that's independent, if you need a way to remember it on the exam, independent of, well, an AP. All right, so those are a little bit about the wireless local area networks. Now, there are some other technologies that I also want to talk about that they mention here. Now, understand that I'm putting some of these technologies under the personal area network because they do kind of form their own mini networks, right? What is a PAN? All right, well, you're going to say that's something you fry an egg in, or that's a, you know, I don't know, a kid that's flying away from a pirate named Hook, not right? You know, really, no. It's a personal area network, right? And a personal area network is typically just a few computers that a single person is using, hence the term personal area network, right? And there's wired, and there's also a WPAN, wireless personal area network too. Now, you probably are more familiar today with the wireless personal area network than maybe you are with a personal area network. Well, why do I say that? Well, you've probably seen things like Bluetooth. I know, Justin, you use Bluetooth heavily. I know I use it. Fairly easy to get devices paired up. Sometimes it can give you a problem, but you know, for the most part, it's a simple pairing process and it's wireless communication. Well, what's the wired side of this? Well, USB. Believe it or not, USB, the Universal Serial Bus, is actually a mini networking protocol. And you say, well, what do you mean there? 127 devices, believe it or not, can be connected to a single host, right? Now, those of you that know your binary might say, well, wait a second, 127, that doesn't sound like a binary number. 128 does, though, right? So what happened to the extra bit? Well, remember, 0 counts. Well, the reason we say 127 devices, not 128, is because one of those bits is reserved for the host controller, the device that is actually managing all the other secondary devices. You might hear the term, what are they called? Master slave. I hate that term. Those terms should go by the wayside. A lot of times what I do is I replace them with primary and secondary. The primary device is what's controlling the secondary devices. Well, guess what? IEEE 1394, maybe you haven't heard of that. Those of you that are coming over from your A+ training, maybe moving on into Net Plus, should be aware of this, right? That's FireWire. All right, and that's all due to Apple's marketing and stuff, but the IEEE standard 1394, same thing, right? You can have up to 63 devices connected to a port. And we could probably even put Thunderbolt in here today. It's not called out formally on the exam, but you could throw Thunderbolt in here too, because you can daisy chain wired devices, right? So that's the wired personal area network. The wireless personal area networks that we talk about are things like Bluetooth, right? Bluetooth is one of the most common, and it's been around for a very long time. In fact, maybe you didn't realize it. It goes all the way back to, I think, like 2002. All right, and we have different versions that I want you to be aware of some of their characteristics, just in case they ask you on the exam. Right? Remember that with the CompT exam, specifications mean a lot, so you have to know these, right? It's just sometimes the sheer memorization. So let's go ahead and let's dive into Bluetooth. Bluetooth is a very, again, simplistic way to set up communications, right? And one of the things that Bluetooth does is it operates in the 2.4 gigahertz spectrum, right? It's that ISM band that we've talked about, the industrial, scientific, and medical band. So it operates in the same frequency range, if you will, of other technologies, like, for instance, Wi-Fi. Right? The versions that we have, going back to 2002, very first version, version 1. Version 1, it's actually a 1 megabyte, if you will, or a 1 megabit connection, and it's actually broken up into 2 channels. It's broken up into a 768K data channel. I know I got my notes. So looking at my notes, I'll have to correct my notes here that we leave for you guys in the episodes. But it's a 768K data channel. That was what was reserved for data, because you also had a voice communication part of that was about 232-ish kilobytes or kilobits for an overall 1 megabit transfer speed. Now, there were some of the things that I want you to remember is that when the very first version came out, we lacked what we have today with all the versions after that, and it was a bad security vulnerability. Really easy to get into things like blue snarfing and blue jacking back in those earlier days. You could still do it today, but it's a lot more complex. The fact was there was no secure pairing. All right, when these devices would pair up together, there was no way to secure that, so it did lend itself to attack. And that's what, in 2005, the 1.2 standard would solve. All right, it would introduce secure pairing. That's one of the big differences, right? As far as the communication speeds go, it's still that 768K kilobit per second data channel. All right. But it did introduce the secure pairing. Now, in 2004, they would release something known as the Bluetooth, and it would be 2.0 plus EDR. All right? All right, EDR, another acronym. Sorry to keep feeding you guys and gals out there alphabet soup, but we're talking about enhanced data rate. We would go from 768 kilobits per second all the way up to 2.1 megs over enhanced data rate. Now, it also supported backwards compatibility, and that's the other thing that I probably should mention, is that it was backwards compatible with the earlier versions of Bluetooth as well. In 2007, they came up with like a half-life type revision, 2.1. 2.1, what that would do is that would increase the speeds, if you will, to 3 megabits per second. All right, now both of these, 2.0 and 2.1, also had secure pairing. But here's where I want you to start understanding the distances, right? Because that's one of the things they want you to know about Bluetooth technologies too. How far could a Bluetooth communication reach out and communicate with another device? If we said all things were perfect, all conditions, wireless communications have many factors that can reduce the distance in them. You increase the gain of the signal, guess what? You're going to reduce the distance. You put interference in there, we get radio frequency interference in the way, we get fluorescent lighting, a lot of factors can come into play. So I want you to know the theoretical maximums for the exam. Doesn't mean in performance, in the real world that you'll actually get this, but you can get up to 10 meters for both 2 and 2.1. All right, that is our common range. Actually, it's pretty much our common range for all of these, all of these Bluetooth standards is that it's about 32.8 feet. All right, now, I don't know which one they're going to give you on the exam, and I'm not one of these ones that can go from the imperial system metric and back, right? But there is one that I also know, and I've always told our students, you should know this. 10 meters, right? Well, how about we start out with 1 meter? If they say it's a 1 meter transmission distance, 3.28 feet. If it's 10 meters, well, guess what? It's 32.8 feet. If it's 100 meters, you're just moving the decimal point, right? It's going to be 328 feet. Now, I just want you to remember that because a lot of the technologies that we talk about across the entire Net Plus deal in those 1 meter, 10 meter, and 100 meter ranges, right? Ethernet cable, maximum distance is 100 meters or 328 feet. So that's a commonality that I want you to remember for the exam. All right, now, in 2009, they would come out with something known as Bluetooth version 3.0 HS. All right, HS just stands for high speed. They're basically just increasing the speeds. Now, this is kind of mind-boggling because they went from the earlier one, right, the 2.1 EDR being 3 megs, all the way up to 24 megs, which is pretty impressive. Now, up until this point, right, up until 3.0, one of the things that we had to worry about with Bluetooth and all Bluetooth communications was the fact that it was very, very power hungry. You just like to scrape that power because what was interesting is the protocol underneath, when you go through the pairing process, right, and these devices, they essentially, they do a handshake, right, and they basically form this trust relationship and the communication's protected. Well, the problem with Bluetooth is that even though that communication, that pairing process had happened, periodically they'd have to repair. And I'm not talking about fix anything, but repairing up together. And every time they would have to do that, well, guess what? That's going to chew up some power. So when 4.0 came out, this one was Bluetooth LE. LE, if you don't know, stands for low energy. In fact, they were raving about it. I remember the special interest group put out this, Justin, and one of the things they were raving about this is they said, you can power your Bluetooth technology with a battery that's less than the size of a dime, and it should last for 10 years. So we're talking about, and the thought process behind this, how many of you have had a cell phone out there with a Bluetooth device, or Bluetooth capabilities in it, and kept it for 10 years? So essentially what they're saying is that the Bluetooth device, the Bluetooth technology would outlast, power-wise, outlast the device that it's in. So didn't really change the speed. So 3.0 and 4.0 all have that 24 megabit transfer speed.
Now, Wes, I got a quick question about that low energy portion. Is that kind of a theoretical, there's a lot of factors that come into play, and am I actually use more energy, or is it like pretty staunchly said, hey, we've reduced it by a factor of 10 as far as energy usage during these handshakes and maintenance periods?
It's the one thing that isn't theoretical. It actually is a low-powered implementation. And as of 2017, I know we don't like to put time frames on these, but I have to because 5.0 is in the works right now. So you don't have to worry about 5.0 because it's still in draft mode. But yeah, that is one of those things where it's not like ranges and distances where it's like, oh, okay, well, I put a metal building in the way. Well, you're not going to get the same distance because there's a building in the way. So great question there. All right, now some of the other ones that we have here, that was just one, and that's one of the ones that have a lot of specifications because a lot of the different versions. Some of these other ones here, like Z-Wave. Z-Wave is a great technology. Maybe you've seen it before. It started back in 2001. And one of the main usages for Z-Wave really is home automation, right? An example would be things like light sensor controls within your homes and stuff, and there's all kinds of different implementations. One of the really cool things about the Z-Wave technology is that just like we talk about the OSI has different layers, the OSI model, well, it's great because the designers, the engineers behind this stuff, all these protocols are just brilliant geniuses, is that they actually put an interoperability layer in there that says, if you follow, whether you're developing the software, you're building the devices that the software is going to run on, if you develop to the Z-Wave standard, all devices will be interoperable. And that's one of the great things. Remember, that's one of the reasons that we kind of stress standards. Right, standards aren't, put in place to make CompTIA candidates just blow their mind with all these different specifications, but it's about that interoperability. Now, understand that it's a low latency transmission, and we're talking very, very small data packets. It also operates in the ISM band as well. It operates at right around 908.42 megahertz here in North America. In Europe and other countries, it's going to be slightly different. It's got a 30-meter range. All right, so be aware of that too. And one of the cool things that I really like about this, and I know that when it comes to things like Internet of Things, right? Because all of these technologies, that's essentially what they're supporting. And I know, Justin, that you've worked pretty heavily with things like Raspberries and stuff. And one of the things I really like about Z-Wave devices is that even though we have a 30-meter range, the messages can actually hop up to 4 nodes. So they can daisy chain across multiple devices. Really cool technology. Here's the drawback. It competes with cordless phones. It doesn't compete with Wi-Fi or Bluetooth, but it does compete with other small devices too as well, but mainly with things like the cordless phones.
Now, Wes, I do have a clarifying question. I think I understand. So if I can jump 4 nodes, does that mean if I have enough Z-Wave components at exactly 30 meters, then my effective distance can be up to 120 meters?
You can extend it. And that's why, and then one of the reasons they did the whole 4-node hop is they thought, well, that should be adequate for anybody's house, right? That, as big as the house is. Now, if you're an athlete and you make a lot of money, maybe you need 5 or 6 hops. Maybe you need to pair them together. But for the most part, they figured that would be adequate for, the average house. All right, so let's see what else. Okay, so the next one we have in here, it looks like we're going to we're the study of bugs here, right? ANT+. ANT+ is another wireless communication protocol, and this one's used all over the place, believe it or not. It's used in things like the medical field, right? Heart rate monitors, right? Monitoring your vital signs and stuff and reporting that information over a wireless communication to a central nerve system, right? Not your nervous system, but a central nerve device that would be monitoring all the sensors and stuff. Things like your tires, right? In your cars, things like tire pressure, right? Home devices. I know fitness monitors are a real big thing right now, so ANT+ is also in there as well. It also has its own interoperability layer too. So if, like Z-Wave, if these devices are developed and made according to the ANT+ standard, then they should be interoperable regardless of the vendor that you are working with. One of the things that it does is it uses asynchronous communication. And the reason for the asynchronous communication, right? Remember we say asynchronous, right? So against, right? Synchronization, where, so it's against timing, right? Chronos, if you will, timing. Why is it against timings, any kind of synchronized timing? Well, that's because what the designers wanted is, let's say that I have to send a communication out to, I don't know, any kind of device, any kind of application. Well, we want it to be able to send at any time it wants, right? We basically only make an over-the-air transmission when required by the application. So that's one of the reasons they're asynchronous. It operates as well in the 2.4 gigahertz spectrum, and it uses something that we talked about in another episode. Remember we talked about code divisional multiple access, and we talked about time divisional multiple access and frequency divisional multiple access. This uses TDMA. All right, so in order to spread that communication, if you will, across the 2.4 gigahertz spectrum, it uses those discrete time slots, and it just reuses the time slots, if you will, across that spectrum. All right, what else do we got, Justin?
No, I do have a quick question about this this ANT+, because I think I've actually seen a device like this where it gathers a bunch of information, like a heart monitor, and then when it regains connectivity, it transmits all of this information, asynchronous transmission. The one question, though, are there limitations to these ANT devices? Let's say I collect a lot of data. Is there like a bandwidth limit, or do you just have to wait until it's done? Do you know?
No, honestly, on that one, I'm not really sure. I haven't really studied on it that much. If we would have any kind of bogging down, basically chewing through all the bandwidth on that one. All right, let's see. What is next that we have here? I guess we got a couple more. We've got one that's been around for a while there, and that one's IR, infrared. Infrared's used in quite a few different products. One of the products I can think of right now that it's used for is things like remote controls and any kind of IRDA-based device. Now, IRDA, just understand that the IRDA, the Infrared Data Association, they're essentially the consortium or group that oversee the standards, right? The one common one that we use today is called, I always call it VFIR, little v, FIR. It's very fast infrared and operates at 6 megabits per second. And essentially what it does is it uses an LED to emit infrared radiation, and then it goes and it shoots through a plastic lens that really focuses it into a very narrow beam. The wavelengths are akin to some of the fiber optic communications that we talk about, right? When we talk about single mode fiber optic communications, the wavelengths are 1330, so 1,330 nanometers, or the one that has the extremely long, like the extremely long range fiber optic communication, the 1,550 nanometers. Now, again, I'm not sure if they're going to ask you that on the exam, but you just never know. They might ask you a characteristic, and if they do, hopefully you're going to be prepared for it. All right, we got two more that we need to talk about, and I'll go ahead and mention the first one here, NFC. We look at NFC, that's near field communication, and near field communication essentially enables your portable devices to establish a communication. And all you have to do is bring them within a few centimeters of each other. And I believe the standard formally calls out like 4 centimeters, but very, very close to each other. It also operates in the ISM band at around 13.56 megahertz. And the data rates here, very small packages, about 106K on up to about 424 kilobits per second. So really, really small, small data packets. And again, I say small by today's standards. All right, last one. Last one we need to talk about is RFID, and again, RFID uses electromagnetic fields to identify and track and tag different objects. It operates at, well, it depends. It's got a couple of different ranges that it operates in. Give you an example of some. They'll operate at around 120K, all the way really up to 10 gigahertz. So you can see there's a pretty wide spectrum that RFID will operate in. Some of the common uses of it are like your smart cards for smart card authentication. That's the 1356 that it operates at, just in the same range, if you will, and frequency as NFC. You can do things like, for instance, tracking animals, goods, people, if you want. Things like your contactless payment systems, if you've ever used those where you've touched your phone to a payment system. Android Pay, Apple Pay, I think, are some of the kinds that we have out there. As well as even your travel documents have RFID chips built into them too. Now, there is one that is mentioned, but I don't have in the list. And why is that? Because we've talked heavily about it in other episodes, and that's 802.11. Go back and watch our episodes where we talk about each one of the 802.11 standards, just in case they ask you a question on it. But remember, the 802.11 is technically the IEEE's implementation of a wireless local area network.
Well, Wes, you've definitely helped us kind of tease through these variety of well, network topologies and associated technologies. But before we get out of here for this part 2, are there any parting words that you would like to leave us with?
Yeah, Justin, I got so excited with all the different ands, the LAN, WAN, WLANs, that I forgot a couple that are important enough. We've got to mention them here, so we want you to be aware of them. In fact, one of them I've actually got pulled up on my screen, and that is what is known as a storage area network, a SAN. Understand that a SAN essentially is a way to aggregate drives together, and typically what happens is you'll have these they call them SANs, the SAN device, right, and it'll have a bunch of hard drives. Now, where these hard drives are located it really could be all across the network, hence the term storage area network. And that what you'll have, depending on how you want to implement this, usually they're fairly expensive implementations. We're talking starting at around, anyone worth their weight, about $50,000 to $70,000, right? So very, very expensive, high-speed fiber optic communications. That's where we get terms like fiber channel, right? And what you'll have is you'll have things like your servers will have what are known as HBAs, host bus adapters, and then they'll connect into fiber switches. And you can see there is a whole bunch of spaghetti all over this diagram because they want high speed and redundancy. So you'll end up seeing that that you have these fiber channel switches, and then you have what's known as your switch fabric, and you can see enough lines here that it almost makes some fabric, and then you typically have redundancy into the storage arrays. And that's essentially what the storage area network is. It's a way that you can give access to networked disks, if you will, hard drives that are in systems that can be distributed across the entire network or in a single enclosure, depending on how you have it set up. Now, one of the other ones that we need to be aware of is what is known as a MAN, all right? Now, a MAN is a metropolitan area network, all right? And a metropolitan area network, I want you to think of it as really the geographical coverage area there is going to be kind of like a city, if you will. That's why they call it a metropolitan area network. And I've got an example of a couple of different technologies here. Nothing really fancy as far as the diagram goes, but Metro Ethernet is one because Metro Ethernet is a cheap implementation that ISPs can provide a service to business users, if you will. The other one is WiMAX. Now, I will say WiMAX. WiMAX was part of that whole 4G technology, long-term evolution. LTE is the one that actually won out, and that's what everybody uses today. But the wireless interoperability for microwave access, or 802.16, was one of those competing technologies, and it literally is what they call a wireless metropolitan area network. Now, a WMAN isn't called out on the exam, but if you're going to talk about a metropolitan area network, you almost have to talk about WiMAX, and WiMAX technically, even though it is a metropolitan area network type, if you will, it is a wireless communication. All right, now the last one that we have to talk about real quick and is one that I don't have a diagram, and I know that you've worked for colleges before, so you probably understand this one really well, and that's a campus area network, right? Here in Gainesville, we have the University of Florida. University of Florida has buildings all over Gainesville, and their buildings are interconnected together, their own network, right? So a campus area network is typically one of these networks that can span across the city, but it's under the control of a single academic institution, right? Hence the term campus area network. UF, again, is a classic example of one of these cans because they have, again, buildings everywhere, and they have one massive network that they're connected to. So just a few things there, Justin, that we had to wrap up. Do keep in mind, though, for your exam, know these different networks, know the different network types, know the technologies that support IoT, Internet of Things. Again, things like your Z-Wave, ANT+, right? Bluetooth. We've talked about 802.11 as well, and you should be doing good for your next Net Plus exam.
Well, Wes, you definitely have some added value there, leaving no stone unturned as we continue our venture into CompTIA's Network Plus. Wow, about messed that up. But we are done with this episode, but we do have more Net Plus coming at you, so definitely stay tuned. So signing off for IT Pro TV, I've been your host, Justin Innocent.
And I'm Wes Bryan.
And we'll see you next time.
Thank you for watching IT Pro TV.